Hello, everybody. Thanks for joining. I'm Nick Yeates, and we're going to start off our monthly developer town hall for Polymath here. So I'll introduce myself and give a little intro for what this is about. And Pablo and Adam are here to go through a couple of things and what they've been up to for the last number of weeks. So, hi, I'm Nick Yeates. I am leading up our community efforts and I'm going to be moderating this developer town hall. So I want to talk about kind of the purpose of the town hall. One of the inspirations we had was from Ethereum's developer meetings and kind of an inspiration for us. And we want to be able to bring technical knowledge and updates to the community, and also serve as a mechanism for community to interact back with us. So we'll be talking about some of both of those. So also I want to state we're starting small at this, and that's fine. I think this is our first live one that we've done, and the community is small, and we're growing it, and I think that's okay, and that's how all communities have to start somewhere. So please keep this, we're going to keep this a technical forum. We do have a method to ask questions for anybody that's joining live and watching. Over on your right, there's a little question mark button that you can ask questions in there by typing, by text. We'll see those and either respond there, or if they're appropriate, bring them up and talk about them. So please keep those to technical only, though, and related to Polymath. So I'm going to go ahead and go into, I guess, an update for myself. And one of the biggest things that we want to focus on from community for the next couple of weeks is a bug bounty. Now, we don't have the details worked out. We're doing that over the next couple of weeks here. But with our Polymath Core release, which Pablo is going to be talking about, we want to get developers out there to send us security and bug fixes for money. We'll be determining on what platform, what the rules are, and how much the compensation is for different levels of bugs found. But if you know developers, or if there's developers attending, like we hope here today, we would love for you guys to listen up and watch our news, and we'll be announcing how we will be doing those bug bounties. And for anybody, I want to be clear that even if you don't consider yourself a developer that is going to be able to find security bugs and even knows how our code base works and stuff, don't even worry about that, because we're going to be coming out with bugs that, a smaller level, or kind of, I don't want to say freebie, but some kind of smaller level, simple giveaways that say if you compile our code base and prove that out. We really want to get people ramped up in any way that we can to be getting involved with us, and we want to help that at a smaller scale, and additionally as well as more professional developers. So look forward to that. From there, I want to go ahead and jump into Pablo and Adam, a couple of our developers, and have them talk about what they've been up to over the last couple of weeks. Pablo, why don't you introduce yourself and take it from here?
Sure. Thank you, Nick. And thank you, everyone, for joining. This is our second town hall meeting, and I hope you enjoy this. So last week, as Nick mentioned, we made our Polymath Core repository public on GitHub, which basically introduces a complete re-architecture of the protocol we have been working on for the past 2 months. With this release, we also presented the SD20 interface, which is an ERC20 token with transfer restrictions on top of it. So a token implementing this interface would need to define some conditions that need to be met in order for transfers to be allowed. So this logic can be completely customized by developers working with this interface, and by default, in our own implementation of this interface, we are using something called like a general transfer manager, which defines some basic rules. So in our own implementation, which comes by default with this protocol, only whitelisted investors would be able to buy tokens from an initial issuance. And on secondary markets, only transfers would be allowed if both the sender and the receiver are whitelisted. But of course, this can be extended, given that our implementation of the SD20 interface follows a very modular approach, which is something that Adam here will talk about in a while. The other thing is that
Pablo,
with the
to that is that we have a blog post out there that explains some of that. So if you want to know any more detail on that, Pablo's written a really good blog post.
Yeah, sure. Can we share the link here on the chat, or I'll share it later?
Yeah, we'll get the link out.
My part. Yeah, sure. So with the release, with the public release of the code, we also released Toro, which stands for bull in Spanish, by the way, which is the code name for our V1.0. And we also deployed the Polymath contracts to Rust and testnet, so anyone can interact with them right now to create their own tokens. The dev team, we already went ahead and deployed a token of our own and a companion security token offering, an initial issuance for this token. So we've been playing around with that at the office, buying tokens and transferring that around. On that note, later this week, we are going to release a very complete step-by-step guide on how to use these smart contracts to issue your own tokens and launch a companion STO for that. So keep an eye for that. And as I mentioned before, part of all this re-architecture that we have been working on for the past weeks and months, they involve making our security token implementation more modular and approachable for developers out there wanting to develop their own functionality on top of it. This modular approach makes it easier for us and for everyone to introduce new features and functionality to the tokens we create. So this is something we really want devs to get, and we want to provide all the tools we can for them, for you to get started building your own modules and of course issuing your tokens, your security tokens. To that end, well, we have Adam here, our lead Solidity architect, who was in charge of designing this modular approach, so he can tell us about it. Adam.
Hey, yep. Hey everyone, thanks for tuning in. So this is Polymath's second webinar, but my first webinar, as I wasn't able to attend the last one. So I'm Adam Dossa, I'm one of the lead developers at Polymath, focused on our Solidity code base and building out the Polymath protocol and ecosystem that Pablo's mentioned. So as Pablo said, this week we're really excited. We've released publicly the new version, so Toro, the new version of the Polymath Protocol, which we think is a great framework for creating, issuing, and managing security tokens on the Ethereum blockchain. So if you're a developer, then definitely keep your eyes peeled for the upcoming bug bounty that Nick mentioned at the front of the call, and definitely go ahead and check out the GitHub repo. We'd love to hear kind of any and all technical feedback on the code and the code and the architecture and anything else. One of the contracts on the repo that Pablo mentioned is the ST20 standard interface, which is the kind of Polymath standard interface for security tokens, which extends ERC20, I guess the most common token standard, and adds functionality for security tokens. So yes, definitely check that out, and we'd love to hear any feedback. So I'm going to take a couple of minutes now to talk about the new protocol, and in particular this kind of modular approach that Pablo mentioned, that we've taken on the blockchain, that we're really excited about. And then once the town hall kind of closes, we're going to do a sneak peek of a presentation on modular security tokens that we'll be giving at events later this year. So stay tuned for that if you want to hear even more about modular tokens. So I guess, I think Pablo covered a lot of this, but very briefly, a modular security token, the idea is that the issuer starts by generating a fairly simple ST20 compliant security token that implements the interface but doesn't have a huge amount of functionality on top of that. and that over time, the issuer or someone that they someone on their behalf can attach additional modules to that security token, to that SD20 token, and each module brings with it some kind of new type of functionality. So a kind of an easy example is that an issuer may create their token for their new security token that they want to create, and then they attach a transfer manager, which would help them manage transfer restrictions on their modules, so on their tokens. And then when they're ready, they would attach an STO or a security token offering module to their token to help them raise funds for their securities. And they can keep on adding new modules and new functionality to their security token, for as long as that token is around. I think the other thing that's worth touching on, so these modules live in the Polymath ecosystem and kind of interacted with through the Polymath Protocol. And Polymath are obviously providing kind of modules for certain types of core functionality. Pablo mentioned the transfer manager, so that's one of the modules, and there's some basic STO modules and some kind of permission management modules. But Polymath, we're really excited to see what the broader community can come up with. We think the possibilities are pretty endless. So there's governance, voting, dividends, ENS registrations, pretty much anything you can think of that can be attached, pretty much any kind of functionality related to securities can be attached as a module to a security token. And it's also worth saying that the idea is that module developers will be able to charge in Poly will be able to charge issuers in Poly to attach their modules to their tokens. So so it's definitely an opportunity to make some money as well. So if you're a developer and you have a good idea for a module, check out the code base. There's a bunch of Medium articles, and there'll be more Medium articles following and sort of giving hints and tips on how to create your own modules. Okay, I will hand back to you, Nick. But stay tuned if you want to hear more about security tokens after the town hall.
So we did get a question around if I'm a beginner developer. I just posted it to that, in reply to that question on top of this GoToMeeting right here, the blog article that we were referring to. But I also posted that same link out to Telegram, to the public Telegram. So if you're in the Polymath Network Telegram channel, but it's also on our blog.polymath.network or .com website also. So if I know that there's a lot of terminology, I think as a person that if you haven't been in this space before, we really tried to make sure that we were bringing both an architectural and developer point of view, but also defining some of these terms that can be kind of confusing and new to people coming into this space on that blog. So please do read into that.
Also, if you have any questions throughout Adam's presentation later on, please make sure to post them here on the question sections, and we'll make sure to get them answered.
Yeah. So yeah, that effectively brings, well, I guess if there's any, we can look through to see if there's any of the questions that would apply. That's a repeat of that question. Tend to trap the value. I'm just going to read this out. We can decide if we want to answer this. Haven't read it all the way yet. Dear developers, may I ask, how does Polymath intend to trap the value that is provided by the Poly ST20 network, i.e., how are Poly holders incentivized, or is the token velocity too high such that it won't trap value? Pablo, I'll let you decide here. I don't know if that's really a technical enough question to answer here. You might have to take it to Telegram, but what do you think? Do you want me to repeat that, or is it something we take offline somewhere else?
Yeah, let's take it offline.
Okay. So if you want to ask that in our Telegram, we can talk to you there about that. All right.
All right.
There's a partner question. I'll answer that off to the side. We don't need to handle that here. How does the process of a legal delegate approving an STO look like, and how much is the cost of a legal delegate approximately? How much of that can we answer, guys?
I can jump in a little bit there. So I guess so in terms of the cost of a legal delegate, that's somewhat variable, I guess, right? Depending on the legal delegate, I guess. But yeah, I guess that question's probably based a little bit around the previous version of the protocol, which had this kind of concept of legal delegates baked in. In the new version of the protocol, we've generalized things a little bit. As I say, we've moved away from these sort of quite specific, not very flexible sort of architecture to this more modular architecture, which is more flexible and a bit more kind of generic. So we don't really have the kind of concept of a legal delegate in the protocol anymore. We will. There's definitely the concept of like delegate in terms of permissions delegate, and you can delegate various permissions to whoever you want to as a security token issuer. And as I said, in terms of the kind of the ecosystem, the idea is that modules will have fees or costs in Poly associated with them, which are levied against the issuer and paid to the module developer. But then, those costs are obviously at the discretion of, can be set by developers who develop the modules, and I guess different types of functionality would have different costs. And I'll talk a little bit. I'll dive into that a little bit deeper in the presentation.
Okay. One other question here that might make sense. Someone's asking about our plan to have a test environment available for these kind of test deployments. I believe that we're not doing too many forward-looking aspects in this. But Pablo, do you want to comment on any of the existing stuff that we have going right now for test deployment?
Yeah, sure. Besides the articles that we have been putting up there, well, which I have one right now, we are working on this step-by-step guide to get a token deployed and an STO launched on top of it. That will be there out there later this week. We also have on the repo, we have all the instructions for someone that wants to deploy our contracts and play around with them. And we also have a demo. It's a command line interface for developers that are running a local node, so they can test an issuance live with it. It will guide you through the process of issuing a token and launching a very simple STO. That's something that we will go over in the next town hall, and we are probably going to release an article on how to use it in a few days. But if you are eager to start working and trying our contracts, you can go over our repository and start reading how to deploy the contracts locally or on Ropsten and get started with that.
Yeah, it was real exciting. Pablo had me on a test instance go and do one of those pretend what did you call it, Toro, I think it was also the name of the coin. And so now I'm the proud owner of fake Toro coins.
Yeah.
So we're starting. Go ahead, Adam.
Yeah, so just to add to that, on that same question from Ryan, so all of the Polymath protocol contracts are deployed today on Ropsten, and I believe, Pablo, are the Ropsten addresses on the GitHub README? I think they are.
Yeah, they are.
Yeah, they are. So the contracts are deployed in Ropsten. So in that sense, they're on the test environment in the sense of Ropsten's a kind of test net. And again, as Pablo says, there's you can pull the code, and there's lots of test cases that kind of give you a good idea about how to deploy the contracts yourself. But certainly on Ropsten, you can kind of go ahead and interact with those contracts today on Ropsten.
That's right.
Okay, we'll take one or two more questions here. We mentioned in the change in protocol. Is there a document that summarizes the differences that were made in the protocol? I know that the blog article that we just mentioned has a bunch of those changes. Also, Adam's going to be going over here in a minute how they modularized the code. And so I think that will kind of answer that question in very deep detail.
That was my answer to the question.
The other one, last one we have here that we're going to answer right now. So issuers, someone's saying, so issuers need to hire legal personnel on their own in order to know what modules they need to add to their security token to be compliant with jurisdiction A, B, C, question mark? I guess he's asking for verification of what he's saying. Can you
Yeah.
read that again?
No. So shall I have a stab at that? So so issues need to hire legal personnel. So it's certainly the case that if you're issuing security on the blockchain, you know, and this isn't such a technical question, I guess, but you know, I'm sure you would need some sort of legal kind of representation or advice or whatever in doing that. So you know, having said that, the idea is that so Polymath is kind of partnered with and works with obviously lots of different people across the ecosystem, and we're actively working on bringing in partners to get them familiar with the protocol and the process and everything else that's kind of involved in launching a security token through the Polymath protocol, and obviously building modules to make that process as kind of as easy and as accessible and cost effective as possible for issuers.
Okay. With that, I think we'll end this portion of this, and we'll move to Adam presenting some of his security token modularization. Adam, I'm going to pass the torch to you. 1 second.
Okay. Okay, let me just share my screen. Okay, lovely. Just great. So it's from my notes. So yeah, so we wanted to spend a bit of time talking about modular security tokens and what exactly that means. What it means in general, what it means to Polymath. So a good place to start is to look back at the ICO market and how it's developed. And that, I think it's useful to start with that review. And you don't need great eyesight to look back at that because really we're talking about the last 12 months. Certainly there were ICOs that happened before 2017. Some on Ethereum, some not on Ethereum. But I think the kind of explosion in activity was largely in 2017. Explosion in activity in terms of the amounts being raised and so on was in 2017, in the last 12 months. So, so how did ICOs start? I guess they kind of started as a novel way to fundraise, and as well as raising funds, obviously the kind of token mechanics help build a network effect and kind of community around a service or a product. But certainly, the start of 2017, pretty much all of these ICOs were entirely unregulated. What that meant in terms of kind of on-chain is that the typical ICO contract was kind of a free-for-all in the sense that it was open to any Ethereum address. So any Ethereum address could send funds or Ether to the ICO contract and receive back tokens in return. There wasn't really this kind of idea of having a whitelist. Wasn't really the idea of having any kind of pre-registration requirements. And the ICOs were pretty much a free-for-all. Certainly there were there were caps on lots of them and sort of defined start and end dates, but otherwise were kind of open to everyone and fully anonymous in that sense. In the sense the investors were anonymous. So I think this has some interesting side effects. There were some kind of network scale effects, and I think the status IM ICO managed to bring Ethereum to a halt for 2 days or something. So there were definitely some interesting effects, and obviously, as I say, these were kind of entirely unregulated. What we then saw happening, I guess, towards the sort of middle or third quarter of 2017 is regulators obviously started to pay attention. Obviously, there were large amounts of money being raised and so on. So regulators obviously started paying attention, and some ICOs started to kind of put together relatively simple whitelists for their issuance. So here by whitelist, what I really mean is a list of a kind of pre-set list of Ethereum addresses, and the ICO contract would check that the address that's sending it funds was in that list. If it was, it would take the funds and issue tokens, and if it wasn't, it would reject the contribution. So you started to see ICOs having these simple whitelists. I think it's solved a few problems. One was it kind of made sort of Sybil attacks a little bit harder. So if you're an ICO and you want to have a fairly sort of diverse community of token holders, then lots of ICOs would sort of set a cap. Maybe you're only allowed to contribute 1 Ether or something. But obviously that's pretty useless if you don't have if you don't limit in some way the addresses, otherwise people can just take their 100 ether, split them out to 100 addresses, and kind of effectively appear to be 100 different people. So I think that was one reason. A whitelist and probably cynically encouraged a little bit of FOMO ahead of the token generation event. There'd be, especially for a capped whitelist, there might be some kind of competition to get on the whitelist before the ICO had even kicked off. So, which is obviously from a kind of marketing perspective was useful. And certainly it was like a nod towards compliance. There was maybe some attempt to capture some of the details of people investing, but it was a relatively light approach, I would say, to that kind of compliance side. And then as we moved towards the back end of 2017 and certainly 2018, I think a few things started to happen. So regulators started to kind of really engage in the crypto space in all sorts of different ways. But obviously ICOs, everyone knows, have generated lots of kind of publicity, good and bad publicity, with examples of good ICOs and bad ICOs. So regulators started to engage more seriously. I think also, in the early part of 2017, the kind of organizations that were doing ICOs were, as I think of them, kind of blockchain native companies, so companies whose business or product was pretty much exclusively orientated around the blockchain. I think towards the latter part of 2017, we started to see more kind of traditional non-blockchain native companies wanting to get into the same space, wanting to get some of the advantages that being on the blockchain gave them, and those companies have a kind of greater regulatory risk potentially than a new startup. So you start to see institutions and organizations doing ICOs taking compliance more seriously. And really what that's meant generally has been, some form of KYC, which is know your client, or AML, it's anti-money laundering process as part of the whitelisting for the ICO. I'll touch very briefly on what exactly a security token is, and the obvious thing to compare it to is a utility token. So a utility token, I think of it as being a token which entitles the bearer of the token to some access to either a protocol or maybe a service, or something, or possibly a product. Usually the crowd sales are going to be unregulated because by sort of definition, a utility token is not a security, so it doesn't fall under those kind of similar security regulations. And that's, I think, say utility tokens is kind of in one category. I think the more interesting category of tokens are security tokens. So how do security tokens differ? I guess they're in some senses, although not exactly, but in some senses equivalent to equities in traditional markets. And generally, I guess the main criteria is that ownership of the token represents some ownership of a real world asset off chain, and that the investors therefore probably expect some sort of profit in either the short term or the long term from holding that token. And the other obvious impact of a security token is that it's regulated under the usual kind of securities regulation, which obviously varies by jurisdiction. And it's worth saying this sort of differentiation between security and utility tokens is kind of a grey. There's obviously a grey area in between. I think there are some tokens that are definitely on one side of the fence or the other, and there's kind of a grey area in between. So to kind of dive into what a security token is in a bit more detail. So on a kind of at a technical level, there are two key things. I think from a kind of legal perspective, they obviously bring with them a much higher regulatory burden, and lots of that is going to be off chain and pre-issuance and so on. But in terms of the on-chain behavior of a security token versus a utility token, I think there are kind of two key points or two key differences. One is that they involve transfer restrictions, and unlike ICOs, which so definitely some ICOs have whitelists and had some sort of restriction on who could buy the token at the ICO. Security tokens involve transfer restrictions both at the point of issuance, so i.e. during the ICO, or as we started calling it, the STO, which is a security token offering, but also, as importantly, during secondary trading. So so if Bob goes and buys some security token during an STO, he's not then allowed to transfer those tokens to Charlie unless Charlie has also gone through appropriate kind of KYC and AML processes with the issuer. So it's that secondary trading and primary trading or issuance restriction. And then the other kind of key difference is around how security tokens are created. So because security tokens represent some or a link to some real world asset, so you kind of can't really kind of create them totally arbitrarily, because presumably the real world asset isn't kind of created at the same time. So kind of having a bit more clarity around how a security token is created is also something that's sort of important to a security token. Okay. So transfer restrictions on security tokens is an interesting topic. There's a few different sort of organizations or companies working on it. So I'm going to briefly touch on what some of those sort of organizations are doing and so on, and where Polymath kind of stands relative to those. So Open Zeppelin has something that it calls TPL. I can't remember what that stands for, but it has something called TPL, which is kind of a transfer restricted protocol for tokens. And Harbor has an R token, which is somewhat similar. And then at Polymath, we have a standard which we mentioned earlier called SD20. So there's a lot of commonality between the standards. They all primarily focus on transfer restrictions, although SD20 also looks at this kind of issue around the creation of security tokens in addition to transfer restrictions. In terms of what a standard means, so I think one important thing that a standard should do is be pretty agnostic as to what the implementation is, and from a kind of code speak, only really define the interface. So the standard should sort of say what how the token behaves, the standard should define the interface, but not the implementation. In terms of why standards are important, I think ERC20 is a great kind of example to use there. So we saw the ERC20 standard really start to get adopted in earnest, say last year and so on. And the adoption of that standard, I think, has driven a lot of this, a lot of the growth and popularity, because it means that third parties, so for example, exchanges is obviously a good example. Third parties can interact with tokens, and the exchange doesn't really care whether the token is a status token or a District 0x token or a Polymath token, provided all the tokens kind of conform to that same standard. The exchange can kind of deal with them in a similar way. So so exchanges are important. Exchanges, wallets are obviously in the same category, custodial services and so on. So having a standard is important. And the SD20 interface, or the SD20 standard, is Polymath's version of the security token standard. So let's talk a little bit more about SD20. So really, when you look at what's missing from the current ERC20 token interface, and there are some other kind of newer token interfaces which I'll touch on a little bit later, but ERC20 is by far and away the most adopted one. The two kind of key things we think are missing, which obviously kind of relate back to what we were saying earlier, is that there's no clear way or consistent way for someone to check the validity of a transfer without actually trying the transfer. So without the kind of suck it and see approach, you can certainly, with the ERC20 interface, transfer tokens, and maybe that transfer succeeds or it fails. There's kind of no way of checking up front without actually doing the transfer whether a transfer is going to succeed or fail. So that certainly once you introduce transfer restrictions, so it's not just about how many tokens you have, it's also about whether the person you're transferring it to has gone through a KYC process, and maybe what the time is, how many months since you bought the token, and those types of things. Once you start introducing that type of logic, this kind of requirement to be able to check the validity of a transfer on chain becomes super important. So that's one thing we think is missing. And then the other bit that's missing is again, there's no kind of clear definition around how tokens are issued and created. And I think, you know, the ERC20 standard doesn't say too much about this. So it defines that you should issue a transfer event whenever you're transferring tokens, but it doesn't say so much about kind of how tokens are initialized. And you know, certainly we've seen lots of kind of token contracts which take different approaches here. So, you know, some token contracts will initialize a total supply and then sell off some of that total supply. Some will start with a total supply of 0 and then create tokens as they're sold. Some have kind of fairly wacky behavior around, say, vesting tokens or other types of tokens. So there's certainly no clear, consistent kind of unified way of doing that. So we think those are the two bits that are missing. And the other thing that's important to say is that the SD20 interface is an extension of the ERC20 interface. So in that sense, it's kind of backwards compatible. So any SD20 token is sort of by definition a ERC20 token, and yeah, so it extends that interface. So let's have a look. So yeah, so some code for people who like code. So this is removing some of the boilerplate and so on. This is the SD20 interface. As you can see, it's basically 2 lines of code, which, you know, I think the ERC20 interface, if you get rid of the boilerplate, is, I don't know, 6 or 7 lines of code or something. So, you know, the intention of the SD20 interface is to be super succinct, very simple, totally agnostic to implementation. You know, it's an interface that anyone can kind of go away and implement them themselves. It's not heavily tied to the Polymath Protocol. So if you want to, you can go ahead and create an SD20 token or SD20 compliant token externally to the Polymath Protocol. We think obviously the Polymath Protocol adds a ton of value, but you know, it's not sort of enforced as part of the standard. And the 2 functions there map to the 2 areas we've talked about. So as a kind of example of how you might use the verify transfer function, so this is a function that checks whether a transfer would succeed if you were to execute it. So you can imagine there's an exchange and that Bob wants to purchase some security tokens on that exchange. So before the exchange sort of allows that trade to execute, the exchange can check using the verify transfer function that Bob is indeed authorized to own that token, and also potentially that Bob is able to withdraw the token from the exchange. So in that case, calling verify transfer with a from parameter of the exchange address, a to parameter of Bob, and an amount of how many tokens Bob is trying to buy. And if verify transfer returns true, then the exchange can go ahead and execute the trade, transfer the tokens to Bob. Everyone's happy. And obviously, if it returns false, then the exchange can obviously not do that. And it's worth saying, you know, often the way DEXs work, or decentralized exchanges work, is that they may call verify transfer to check that Bob is eligible to own those tokens, but not actually execute the transfer until Bob withdraws the tokens from the exchange, which may be a day later or sometime later. So they may call verify transfer without wanting to actually call the transfer function itself. And then the mint function addresses the other problem, and the standard kind of insists, if you like, that all tokens must be created through the mint function. So in other words, that, you know, yeah, so all tokens must be created through the mint function, and any token must have been created through the mint function. So what this means is, it means that for, you know, certainly for clarity and any kind of regulatory reporting or analysis that's needed, it's very easy to see you know, where any token is being created. It's easy to hook additional kind of functionality into that mint function for, you know, for example, for reporting. And certainly within the Polymath kind of implementation of the SD20 security token, this is enforced at a protocol level. So at a protocol level, we enforce that only tokens can only be created through the mint function. So that's the SD20 interface, and then enter modular security token. So what is a modular security token? It's really Polymath's implementation of an SD20 token. So we've developed this protocol which allows issuers to create simple SD20 compliant tokens and then layer on top of that sort of simple SD20 framework individual modules which they can select and choose. And each of those modules provides additional functionality and flexibility to the issuer or potentially to the investors or holders of that token. So the basic idea, as I said, is that the issuer starts with this kind of bare bones SD20 security token, and they then choose modules from the Polymath ecosystem to add to their token. So you can kind of think of it a little bit like an app store for token functionality, where issuers, having created their SD20 token, can kind of go to that app store or module store, select what tokens they want to add to their module, what functionality they want, and with a couple of clicks through the dApp and obviously a transaction on the blockchain, add those modules to their token. So we think this has a bunch of different advantages. It's flexible, it's kind of user friendly in the sense that issuers don't have to decide everything up front when they're issuing their token. They don't have to have every single decision made before they issue their contract on the blockchain. They can create this sort of basic SD20 token and then add and remove modules as their process develops and as they work out exactly what type of security token offering they want to do, or exactly what the regulatory requirements are around transfer restrictions and so on. It also one important part of the kind of modular system is that the issuer remains entirely in control. So from a kind of access control perspective, the issuer is the only person who's allowed to add and remove modules from their token. So the issuer kind of maintains that full control. And what it means for SD20 is it means that we're able to enforce SD20 compliance at a smart contract level, which obviously kind of gives everyone, from the regulators to the issuers to the investors, that kind of confidence around the behavior of the token. So one kind of consequence of this very flexible approach is that it is related to how it interacts with immutability. So one of the advantages of being on the blockchain is that smart contracts are immutable. You know that if someone's issued a smart contract, that they kind of can't change it after they've issued it, or the restrictions on how they can change the logic in that smart contract after they've issued it. So one of the things we thought about is how that maps to the world where issuers may want to modify the behavior of their SD20 token through these modules. And I'll talk a little bit about how we solved that in one of the following slides. But it's definitely something to think about. So, okay, so I'm going to talk in a little bit more detail about an STO module. So as a reminder, an STO is a security token offering, so the kind of analogy to an ICO, but where the token being issued is a security token. So with modules in the Polymath protocol, there are various, so every module has a specific type associated with it. So the type of a module might be an STO, or it might be a transfer manager, which is a module that helps you manage transfer restrictions, or it might be a permission module, which helps you manage the permissions on your modules and on your token. So every module has a sort of specific type, and that specific type kind of maps to certain access or behavior in the token itself. So a clear example of this is that the STO module, or a clear example is that only modules of type STO are allowed to call the mint function in the security token. So in other words, only STO modules are allowed to create new security tokens. So what this means is that it kind of gives a very kind of clear definition of behavior, and it kind of encapsulates that bit of functionality very kind of cleanly and clearly. And it's still pretty flexible. So for example, the other thing that's worth mentioning is that you can chain together modules of the same type. So maybe, for example, that an issuer wants to have 3 different types of STO module. Maybe they want one STO module to manage their pre-sale commitments, where they've maybe offered, off-chain, they've sold some tokens pre-sale. Maybe they want one STO module to manage vesting tokens, maybe the founder tokens, which vest over some time, and then one module maybe to manage the more public sale, where they're kind of going out and publicly raising funds. So they might have, in this case, 3 STO modules attached to their token, and the protocol kind of handles chaining of those modules. So that's chaining modules. And then in terms of the immutability point that we sort of touched on the previous slide, so an issuer has the option, once they're comfortable, once they've set up all the modules of a particular type, so in this example, they've set up those 3 STO modules, and they're kind of comfortable that they're set up and created correctly, and that they're not going to change their mind, they can then lock down the STO module type in their security token, which broadly means that they're not allowed to change, they're not allowed to add or remove any STO modules going forward. So that means that they've kind of maintained that full control and flexibility until they are ready, and it hasn't delayed them, kind of getting on with issuing their token and all the other bits. But that when they are ready, they can lock down that module type, which then gives investors that kind of guarantee around behavior. Gives the investors a guarantee that the issuer isn't going to somehow change the terms of the STO or something similar to that, down the line, or add a new STO to mint themselves additional tokens or something like that. So it kind of gives the investor that immutability guarantee whilst maintaining flexibility for the issuers. So yeah, so I wanted to again, some more code for people who like code. Solidity code. So this is slightly stripped down. There's a couple of things missing, but it gives a kind of idea of how easy it is to build new modules for the Polymath ecosystem. So this is an example of an STO module. So you can see there's certain kind of certain structure you have to conform to. It has to inherit from I module, which is an interface provided by Polymath, and there's certain things you have to pass in, which is broadly the security token address and the poly token address to the I module constructor. There's then some kind of a little bit of boilerplate code around the initialization of that module. So all modules are created via factory contracts, which kind of gives an easy way to kind of create lots of identical modules, which are identical apart from maybe different configuration or initialization. So all modules are created through factory contracts, and there's this kind of a structure that you can use to initialize, that the issuer can use to initialize those contracts when they're created and attached to their token. So in this case, in an STO, some of the kind of parameters they might want to initialize is start time, end time, and cap. And that's pretty much it. And then you can kind of go ahead and write the functionality. So in this case, there's a generate tokens. This is just a sort of dummy contract. There's a generate tokens function, which lets the issuer generate as many tokens as they want to whatever addresses to whatever addresses they want. And there's a bunch of other stuff you kind of get for free if you're using the I module interface. So you get access to kind of permission modifiers, which can be set by the issuer using a permission the permission module, and various other nice bits that you can get for free from the I module interface. That's that. I realized I missed one slide, so I'm not sure, I must have clicked twice. So I'm just going to go back and cover that here. So that was this slide. So I want to talk a little bit about the module ecosystem. So whilst Polymath has obviously developed the protocol, and we've written and will continue to write modules for sort of certain common core types of functionality. So permission manager is an easy example of that. We're super keen to encourage issuers and third parties and developers to create their own modules within the Polymath ecosystem. So we want the ecosystem to be open. So when an issuer attaches a module to their token, it's possible for the creator of that module to charge the issuer a certain amount of poly, like a known amount of poly. So maybe you charge 1,000 poly to add your module to a security token issue, or maybe 100 poly, or whatever an appropriate amount is. Modules can have these kind of upfront fees, so the cost to add the module to the token, which is paid by the issuer, And they can also have ongoing fees. So kind of example of where that might be relevant is if you're a KYC provider, maybe you want to charge an issuer 1,000 poly to add your module to their token, and then an additional 100 poly for every investor that you successfully KYC and add to their transfer restriction module. So so there's definitely opportunities for developers to kind of earn revenue through building modules and adding them to the Polymath ecosystem. So all modules are added to this kind of central repository, which is, say, acts kind of like an app store, I guess. And every module has a reputation associated with it. At the moment, the reputation is driven by which issuers have used which modules, and that is work in progress, and we're looking at ways to make that to improve that. At the moment, there is a kind of centralized aspect to the module ecosystem for quality control. But again, this is a work in progress, and we're actively researching, doing analysis on how we can improve that approach and use some of the kind of community involvement to both for kind of quality control and reputation and so on in this module repository. And we're putting together a kind of clear set of guidelines and interfaces to facilitate third parties developing new modules. So keep an eye out for those. Okay, and then I'm going to flip past these two. So just very briefly, I want to talk about a few of the things we're looking at, which are kind of future-facing research analysis. So we're looking at some of the new token standards, so particularly ERC 777 and ERC 827. Lots of those new standards are kind of orientated around the way that tokens interact with dApps or with other smart contracts. So we're looking at that for the Polymath Protocol and Polymath Security Token. We're looking at how to sort of integrate some of these identity standards, particularly ERC 725, into transfer restrictions. So there are some standards starting to emerge which help manage on-chain identity, and we want to, we're actively working with some of the authors of those standards to work out how to integrate those into the Polymath protocol. More flexible interactions between modules and security tokens. Something we're sort of thinking about, whether there's a way to generalize that or improve the way that modules and security tokens interact. And as I just mentioned, an improved reputation system for modules, leveraging community involvement is something we're also keen to do. So those are some of the areas anyway that we're looking at in the future. And that's it. I haven't looked at any of the questions, but if there are questions, we can now take a look at them.
We've been getting a bunch of questions. I think Pablo's been answering a bunch of them too. Pablo, is that right?
Yeah.
Is there anything that apply to Adam?
I think I answered most of them. There's a new one here. Victor asking, does the central repository for modules exist? If not, where will it be, or how will it be structured? So can you explain, Adam, how this repository for modules will work?
Yeah. So it exists in the sense that it's deployed on, so the central repository is a smart contract. Maybe that wasn't clear from the presentation, but the central repository was a smart contract, or is a smart contract. It exists in the sense it's deployed on Ropsten. I think all those addresses, it's deployed and verified on Etherscan and so on in Ropsten, and obviously the code for the smart contract is on our GitHub. So you can kind of, if you're a developer, I'm not sure, Victor, if you're a developer or not, but if you're a developer, you can go and look at that code. And then obviously on top of that, we're building, UIs, dApps, effectively UI and UXs, which, make interacting with that repository and seeing what modules are available and so on, user-friendly and accessible, where you don't have to sort of interact directly with the blockchain.
Was there any other questions that would make sense to ask? Or were they all answered already in the chat or in the typing? I didn't see any that were very super specific. So I think with that, See if there's any others. No, I think we're good to go. I think we're done. So Pablo, Adam, thanks. Adam, you know what? I'm going to tell you the truth. That was amazing. Wow, that's some good content, and it's going to be well received. So I'm glad. Those were great slides. Thanks a lot.
Thanks.
Thank you,
everybody.
Guys.
Thank you a lot. Have a good one.